This video is mostly for myself, just to capture the last couple days of research, and but I figured I'd record it and upload it to YouTube in case anybody else finds this information useful. This video is going to be on uncensorable APIs, strategies for building uncensorable APIs using the Ipfs Pub Sub and the circuit relays. So it's mostly going to be high-level talking, but I'm going to point out where the code lives for some of this code. So little backstory as to what got me thinking about this is I've got a wallet app that I've been working on for the last few months at wallet.fullstack.cash. This is what it looks like. It's a Bitcoin Cash wallet. It handles tokens. And anyways, what happened was someone in China needed to use it. Actually, someone in Venezuela hired someone in China to do translation for them. And that's the great thing about Bitcoin Cash is it supersedes borders. It's uncensorable. It's great for, it's internet money. So it doesn't matter what country you live in. If you're doing work for me and it involves the internet, I can pay you. And so my wallet's been working really good in Venezuela. However, when this Chinese woman tried to use it, it didn't work. The website was blocked by the Chinese firewall. And one of the techniques that I follow for creating the app to be uncensorable is if you scroll down to the footer, there's a link for different ways to access it, like over Tor. Tor doesn't work in China. It's super locked down over there. That's not an option. But Ipfs did work, so you can. This same web app is packaged as a static web app that is deliverable over the interplanetary file system, Ipfs. So in fact, you can see it here. This is an example. This is a gateway that we run at fullstack.cash. But you can put this hash into any Ipfs gateway, of which there are hundreds on the internet. Any gateway can serve any content on the Ipfs network. And so she was able to access this front end over Ipfs from within China, but it didn't work at all. There was no balances. She couldn't send or receive because the back end is a REST API. And so the best way to describe that as this, what I call the cache stack, which is the service that fullstack.cash uses. So this is like the wallet app at the top. It uses the BCH.js JavaScript library, which then talks to the REST API, which wraps all these lower pieces of infrastructure like the full node and the indexers and the token index. And so this part is what I had effectively made uncensorable by putting on Ipfs, but it still needed to talk to the centralized backend, and that's what got blocked. So this was an excellent learning experience, and it raised the question, how do you deliver a REST API to someone in China? And this has been the question that's kind of been driving me nuts the last couple of days, because I build uncensorable websites. In fact, I own uncensorablepublishing.com, and I've got some videos on here on how to build uncensorable web apps. And so this was an interesting question, is how could we pipe a REST API through the Ipfs network and therefore make it uncensorable as well, make that back end uncensorable. So this is the backstory and the problem I'm ultimately trying to solve with the prototype and demo that I'm going to give here. And I'm going to talk about different strategies, not just one strategy, but a range of strategies for building uncensorable APIs. And an API is just a way for two computers to talk to one another. That's what an API is. Pipe that API over Ipfs. So Pub Sub and circuit relays are two features that were recently developed in Ipfs. They've been in Go Ipfs for a while. They recently came out of experimental mode in the JavaScript version of the library. And so what I built is a JavaScript example, and it's here on GitHub, called Ipfs Pub Sub Prototype. It's on GitHub under my /Chris Troutner thing, and there's instructions. And the code here sets up two nodes. It sets up one node in the web browser, and it sets an IPFS node, not like a Bitcoin node. An IPFS node in the browser using the JavaScript IPFS library. It sets up a node in Node.js JavaScript, which is also JavaScript, but a different operating environment. And then it lets those two talk to one another through a circuit relay, which is a third node. And so this is how circuit relays work, is you've got two nodes that want to talk to one another, but there's a firewall in between. But if they can both access another computer that can operate as a circuit relay, that computer or that node can act as a bridge for these two nodes that want to talk to one another. So that's the idea behind circuit relays. And they're an excellent tool for circumventing censorship. And then the other major feature is PubSub, and so that's short for publish subscribe. And I'll go into more detail on that, but the important basic architecture to understand this demo and why it works is there's three nodes. There's the web node, in the browser, and that's like this app. That's like a wallet app. That's something that some sort of useful thing in the browser, but it needs to talk to essentially a server or a non-browser computer that can do some heavier computing and have things like resources like full nodes and indexers and stuff to talk to. So that's the idea, and then there's this relay node in between. But the web browser is running JavaScript, and the server-side node is running JavaScript, and they talk to one another. And so in this demo that I put together, I've got two folders. One for the browser, which creates a Gatsby website, which is this is a Gatsby website or web app, and this website, uncensorablepublishing.com, this is a Gatsby web app or website, and this is actually the template that I used, that I started from. And basically, it's all about how do you get these two to talk to one another. This Node.js app, this is what most sort of industrial JavaScript software is written on. So if you look at the cache stack, this JavaScript library works both in the browser and on Node.js. The REST API runs on Node.js on a server, and then it wraps these other pieces of infrastructure, which typically run inside Docker containers. And so the problem that I'm trying to solve here is how do you make the app communicate with the REST API in a way that is very difficult, if not impossible, to censor? How do you prevent that communication from being stopped by a firewall? And so I've got the app. If you load the browser side up, there's instructions that you can read on how to, and you follow the instructions, but ultimately you're going to get to this web page. There's not much going on here. It tells you to open up the web console, which I have open here. It's a very simple example where it's using this pub sub channel, so it's a channel that both of the nodes subscribe to. And so when one of them publishes something to the channel, everyone who's subscribed to the channel gets a copy of it. So you can see two types of messages flying through here every 10 seconds. One from the Node.js app and one from the browser app. So the ones from the browser are being generated by this app in the browser, and the Node app is being generated by this one right here in this terminal. And so this is just simulating the type of communication that would happen between a web browser and a REST API, a server running a REST API. And so they were able to connect to each other and through a circuit relay node that I set up. Now, the other thing that's going on here that's not obvious is that just like you can access wallet.fullstack.cache, but I also took that URL, but I also took the same app and serve it over IPFS, and you can get it in a gateway, which is what makes the front end uncensorable. this app is also running on a local IPFS gateway. So I can do local development and run this locally on my computer, but when I publish it, not only is so there's two pieces of the uncensorable architecture going on here. There's the app itself that is delivered over IPFS and rendered in the browser. So that's hard to censor, the actual web page. But then that web page needs to communicate with a server. The front end needs to talk to the back end, and that's what I'm demoing here. That's the sort of unique thing using the circuit relay and pub sub. So the whole thing is now essentially uncensorable, assuming those nodes can talk to one another. And that's sort of where the dragons lie, is trying to get these things to talk to one another. And so this was the bulk of the work of my research, was getting it not just two nodes like on two servers where you have more control, but actually getting it to talk to the browser over WebSockets. So there's a few different architectures that this could be used for. So I've given the example of wallet.fullstack.cache and how I could use this idea there. But then the actual implementation, there's different ways I could do it. Like the centralized model, the easiest, most centralized way of solving this problem, if I go back to the cache stack, would be to basically just bolt on an IPFS node to my REST API and then add support in the JavaScript library for using it just so it has an alternative communication channel. So rather than trying to use the normal REST API HTTP calls that is normal in the industry, the communication channel would happen over IPFS. And so that would be the easiest way for me to expand my services to repressed places like China or Russia or other places that I expect will crack down a lot harder on cryptocurrency and try to prevent their citizens from using cryptocurrency and all the freedom-enhancing things it does, like end-to-end messaging and stuff like that is very important for people to have and is not something governments really want their citizenry to possess. And so that's my main motivation. So that's probably how I'm going to do it. But then there's other models that are worth discussing here. One of them is a federated model. So rather than wrapping all this infrastructure under one centralized REST API, what could happen, what this technology could unleash is, if anybody's familiar with the Electrum X network, that's actually a federated model where anyone can run an Electrum X indexer, and then anybody running the Electron Cash wallet, that wallet will just randomly find and pick one. And so that's a federated model where you have redundancy and decentralization because you have an option, you have one of several different instances that your wallet can talk to. And so that's a federated model. And that could even be wrapped in a REST API and monetized by using like a jot token scheme where the library anybody could run the server and they could make money by running the server and offering that access to the network. And so the wallet or library wanting to talk to it would negotiate some payment up front before it actually got access to the working API. And so each one of these little boxes could be like their own sort of federated network of providers that are competing. And all you would need is a coordination layer, and that is a good segue into the serverless model, which would, I think, be the ultimate, where there is no back-end server. The apps are just talking to one another in a ideal peer-to-peer environment. And a good example of that is how I've actually been experimenting with this pub sub. This Merit chat is another prototype that I have on my GitHub profile, where I spin up 4 different IPFS nodes. Now, these are all in Node.js, so it's not dealing with the browser, and that makes things a lot easier. But what I was simulating here was 4 or 3 wallets and then 1 relay or coordination server or node to basically man the pub sub channel as like a person of last resort. So there's not really a server here. It's really just nodes and with one sort of guaranteed to stay up to maintain the pub sub channel. And they're not using a server to coordinate. They're talking to one another, and they're coordinating amongst themselves without any need for a centralized server or any point of failure, even for the communication part. And this was the inspiration for this collaborative coin join that the Permissionless Software Foundation is going to be working on, where we'll implement this into a wallet, a Bitcoin Cash wallet, where the wallets will coordinate among one another to create a coin join transaction, which provides financial privacy. And it'll be robust using this IPFS pub sub scheme, where there's no central server. There's no need for a central server to even coordinate communication. They'll all be able to use pub sub channels to find one another, and then they'll use end-to-end encryption and pub sub channels to talk to one another securely. And so this is another option. So I'll wrap it up here. That's just a summary. Again, this was mostly for myself. This is a really powerful and just general approach to providing APIs. And APIs, as the Amazon Web Services model has shown us, is incredibly valuable. There's money there. People are willing to pay money for internet services. And so if you can offer those in a way that can't be easily censored, that makes them all the more valuable, and it means that the market you can offer those services to is much, much larger, particularly if you're trying to sell something valuable like end-to-end encrypted messaging, or uncensorable money, or publishing uncensorable content, like a Filecoin bridge or something like that. Like, there's plenty of these scenarios and services, or even just accessing Twitter or Facebook. Most of those things are banned from people in China. So if you could find a good way to pipe that information to them, because VPNs are pretty well known at this point. China's got a lot of tools to shut those down. And I'm really looking forward to digging deeper in here, and I hope I get more opportunities to interact with people in repressed countries, so that they can, try sort of trial by fire and try and see how this works. Because the technology's there for us to enforce our rights to privacy and our rights to free speech, and the citizens have the tools to protect themselves against their government.